All right, guys, today's a brand new concept. This is polar graphing. Today we're just basically plotting points. We are going to look at lines and circles because they're very basic equations in polar graphing as well. And we're going to talk about finding distance between 2 points in polar graphing. Those are the three basic concepts today. In rectangular coordinates, you went left or right and then up or down. Okay, and every single point on the coordinate plane had one name, right? Polar graphing uses circles, and air traffic controllers use this kind of thing because it records the location using the distances and angles. So they, I think, use off of north, and then they use how far out the plane is from the airport. I think that's good on that one. So in a polar coordinate system, the fixed point, which is still going to be the origin, but it's called the pole. It's like you measure out from this pole, okay? It's, again, I'm just going to call it the origin. The polar axis is an initial ray from the pole, and we're going to use the positive x-axis. Air traffic controllers probably use due north, but we're going to stick with the positive x-axis as where we start measuring from, okay? And then positive is going to be around, like we always do, up into the first quadrant and around. Negative would be down into the fourth quadrant. Polar coordinates are in the form r theta, okay? In other words, r is the radius out to where we measure it, and theta is how far we turned. Now, if Hofbauer ran the world, it would be this way, because this is how I think of it, okay? You're going to turn, and then you're going to go out some radius. So I always do that first, but it doesn't matter. The theta is called a directed angle. All right, to graph in polar coordinates, remember positive indicates counterclockwise, negative is clockwise. Now, this is the weirdness. If r is positive, you go forward along that line. If r is negative, it lies on the opposite ray, they will say. I'm just going to say we're going to back up. Let me give you a couple examples so this makes a little bit of sense. This is a piece of polar graph paper with the 12ths labeled. So pi over 12, pi over 6, pi over 4, pi over 3, okay? We're going to use this same kind of graph paper, but it's probably only going to have the thirds and sixths labeled, just like we usually count. But in between there, in between pi over 6 and pi over 3 is pi over 4. Everybody seeing this? Because when they're not labeled, you're going to have to know where those are. Now, let me give you a real quick example of what I'm talking about when we graph this, just because it's not that hard. If we had 4 and 3 pi over 4 as the spot we were supposed to graph, you would start measuring from here. You'd go around to 3 pi over 4. So now if I was standing right here facing 0, I turned until I'm facing 3 pi over 4. This means I go out 4 radiuses. Well, this is a radius of 1, 2, 3, 4. So right there would be the point 4, 3 pi over 4. Doesn't seem that complicated, does it? Okay. So here's an example. It said graph 3 pi over 4, so they went around in the positive direction to pi over 4. Again, it wasn't labeled, but it's between pi over 6 and pi over 3. And then they went out. Be careful, this always messes with me, but you do have to count this circle right here as a radius of 1, then 2, then 3. So P was right out here, 3 units out on that radius. All right, now we get the weird stuff, okay? Let me go back to the original here and do if we had changed this to a negative angle, everybody thinking about this? Negative 3 pi over 4 would be in what quadrant? Instead of going 135 this way, you'd be going where? Yeah, you would be down here. Okay? So a negative 3 pi over 4 lands me down in this quadrant. And then it said to go out 4. So I'd go 1, 2, 3, 4. And I'd have negative 3 pi over 4 with a 4. Now, they get even trickier. You can have negative 2 and pi over 2, we'll say. So that would go to pi over 2, but a negative here means you back up 2, so you end up down here. So this means rotate till you're facing pi over 2, but then back up 2 units, or use the opposite ray. And then the really tricky ones would have a negative negative. So if you had negative 5, negative pi over 6, this means rotate. Okay, pi over 6 was 2 of these, but you got to rotate a negative pi over 6. And then a negative 5 would mean you have to back up on the other end of this opposite ray 5. So you'd end up 1, 2, 3, 4, 5 out here somewhere. All right, so those are the options. You just draw the point. Yep, you're plotting a point. This question had a negative negative, so I was trying to give you a heads up here. At least it's in degrees. It says rotate 120 to the negative, which would land you here at this 240 line. But because this is also negative, I don't stay there. I back up on the opposite ray. Instead of going forward 2.5, I'm going to back up 2.5. So basically, if you rotate it around 180, that would be here, and then you'd count 1, 2.5 radii. So it is this point, not the line. Okay, so if I do it in blue, the actual point we were talking about was here. All right, these say to just try it without graph paper. So if I had to graph this, I would say I'm going to go 45 degrees and then out exactly 2 units and put my dot where that was 45. This would be 2 pi over 3, which is in this quadrant, right? 2 pi over 3. Uh-oh, but what am I supposed to do then? Does anybody remember what a negative r meant? Yes, so instead of going out this way on the 2 pi over 3 line, I have to back up 1.5 units this way. So I would wind up down here somewhere, where this is 1.5 units long, and this was like 2 pi over 3's opposite line, which would be, if you're looking at this one, 2 pi over 3 straight across would be 5 pi over 3, right? All right. So real quick, a couple more examples, and then I'll let you do some. Negative 30 would mean you just went this way 30 degrees and then out a positive 3. Okay, what would that tell me? Describe this for me real quick. Where should I rotate? Do I go up or down pi over 2? It's positive. So I just go up here to pi over 2 line. But what does it say to do then? Back up 1. So you would be right down here. This would be 1 unit. Okay. Are you getting the idea that these can have more than one name? Anybody figure that out yet? This would also be called positive 1, 3 pi over 2, yes? That same dot has another name. All right, this is go around to 240, which would be down here somewhere, and then go out 2.5 units. Okay, describe this one for me. Which way do I rotate? Down. 5 pi over 6 would be almost to 180. And then on that line, after I went a negative 5 pi over 6, it's a positive 4, so I would go out whatever 1, 2, 3, 4 units was. All right, let's try it on the graph paper, and I'm going to skip these because I think you got it. All right, well, I don't know if you have these two, but let me do these since we have graph paper. Negative 7 pi over 6. If it's easier, put it in degrees, but 7 pi over 6 normally is to here, right? So it was 180 and one more. So a negative 7 pi over 6 is going to go this way and one more. So you're on this line. Then what do? I'm on this line somewhere. I go out 1.5. So I'd be right here. That would be point R. This one is a negative negative in degrees. 135 would be this line right here normally. So it would be 1, 2, 3 lines back from 180. But I'm supposed to go negative that much. So I'm going this way. Negative 135 would be 3 lines back this way from 180. But then it said negative 2. So where am I actually going to plot this? What quadrant is this point going to end up in? Quadrant 1, yes. Because instead of going out this way to, I'm supposed to back up to. The line would be 45 over here. 1, 2 would be right here. So another name for that point is just 245. All right, you finally have this one? Yeah. All right, where are you going to put 3, 60 degrees? We've watched a million examples now. Go to this 60-degree line. Make sure you count this first one as 1. That's what I usually mess up. Oh, they're even labeled. This one's 2 and this one's 3. At least on mine they're labeled. Is it just like that on yours? Nolan, please be doing this. Everybody good? Number 2. Okay, already into radians and negative angle. Normally if I went 4 pi over 3, I'd go around to here. But what am I supposed to do instead? Yeah, so instead of going to 180 and 2 more, I'm supposed to be going the opposite way. So I'm going to go pi and 2 more, and it's going to wind me up here. There's negative 4 pi over 3 is this line right here. And how many units am I supposed to go out on that line, or am I supposed to back up? Go out 4. So 1, 2, 3, 4. Okay, so what's another name for that point? What's an easy name? Yeah, 4, 2 pi over 3. Okay. Number 3. Okay, negative, negative. What does this mean? Go down 150. So from 360, if I backed up 150, I'd be at 210. Yes, backwards on that line, which will wind me up straight across the circle over here on the 30 line. And I'm supposed to go back 2.5. 1, 2.5. So another name for that, 30. Oh, that's not what I wrote though. 30 degrees and 2.5. And I already have Kelsey convinced that the order should be angle first. Can anybody give me another name for that one? Because there's actually more names. Okay, yeah, you could change it to radians, 2.5 pi over 6. Can anybody give me a name that starts with a negative 2.5 but would have a positive angle? Christian, were you thinking? What did we actually do? Where did we go to? Instead of going negative 150, we stopped at 210. So if we had said go positive 210 and then back up 2.5, would have been the same place, right? So what do we got here? Negative, negative, positive, positive, negative, positive. Yeah, good job. Went all the way around here, negative 330, and then out 2.5. So there's the positive negative name. Nice. All right, so that's what's coming up here. Multiple names for the same point, okay? And basically it says on theta, you could obviously add or subtract 360, and you could add or subtract 2 pi, but that doesn't do a whole lot. You could also do the opposite of the r and add or subtract 180 or pi, and so on. So let's try to think this through. Find 4 different names that name t if we can only use values of the degrees between negative 360 and positive 360. In other words, we can't just cheat by keep adding 360 over and over and over. That isn't what they want. So it's right now it has a nice easy name of positive 135 and out 4. We're supposed to come up with 4 more names. Anybody? Well, what if we'd gone negative angle? What's 135 minus 360? Negative 225. Does that seem like it would be the right spot? Okay, negative 225 and then out positive 4. Okay, what if we had gone all the way around and then backed up 4? Where would we have landed before we started backing up? Can anybody tell? What's the other half of that line? 315. So if we'd rotated around 315, we could have then backed up 4. One more, negative, negative. What is the negative angle that would get me to 315? Negative 45. And then we could have backed up 4. Oh, that's only 3 more names. 4 it said. Well, yeah, I'm going to count the first one. Because otherwise we have to keep adding. We could go all the way around to here. We already did that one, didn't we? No, that would be yes, we did. Okay, I'm giving up. We're going with there's 4. All right, this says do the same thing if it's in degrees or radians. You have these 2 on your notes, it says. Do you have these 2? Okay, so do you have graph paper? No? This one is in degrees. Let's see if we can do it without. Where's 240 at? This is a 60-degree angle in here, right? It's 60 past 180. So there's the 240 line. So what's the other half of it? That would help us. If you take off 180, the other half back here would just be at 60. What if it was going negative? Negative 120. Okay, some of those will help us in a minute here. But if we went out 5, so we're out here at 5 units out. Okay, so we have 5 240. Anybody got another one for me? 60 degrees. No, you're right, I think. Turn 60, but then back up 5. Is he right, guys? Nice job. Anybody else? Okay, so we rotated negative 120 and went out positive 5. What are we missing? The negative negative? Okay, so this one isn't really on the picture yet. If we had to rotate all the way around to here, nice, negative 300, and then we would do what? Back up 5. Good job. All right, it's easier if I give you a graph paper. If I give you a graph paper on the quiz, it'll be easier to do that question. So let me steal a piece of graph paper if I can somewhere. We need radians for this question though, right? Okay, so here's a piece of graph paper. And it says we're supposed to go to pi over 6, which is here, and out 2. So there's one name. We need to stay in radians. Can't just switch to degrees. I mean, you could, but then you have to switch your answers back to radians. What is the same amount going all the way around negative? Can you tell? If you went positive 1 notch, you would go what? Yeah, that's positive pi over 6. How far is that if we start here and go all the way around to there? Well, 2 pi minus pi over 6 is 11 pi over 6. Isn't that where this spot is right here? 1 this way. But we want to go negative 11 pi over 6, so that would go all the way around to here. So actually we did this in the wrong order, but so negative 11 pi over 6 would end us at the same spot. So would be a positive 2 or negative 2? Positive 2. Okay. What else? What's halfway across? Pi over 6. If we add pi, we'd be at 7 pi over 6. So if we had rotated positive 7 pi over 6, we would have had to what? Go back 2. Okay, and if we rotated this way, what would that be? How much would that be? Yes, good job. Negative 5 pi over 6, and then from there we would still have to back up 2. Just look at your symmetry, guys. If you rotate this way, it's positive 5 pi over 6. The same amount this way is that negative. All right, so multiple names. 2 more ideas today. Polar graphing. That we're going to cover the very basics today. A polar graph is a set of all points that work in our theta. We're going to do some really fun ones tomorrow. You're going to like it. If you look at the very, I think it's the back page in your packet. Yes, the very back page, if you have your whole packet out, we're going to draw like flowers and stuff tomorrow. Okay? All these cool ones. But what we need to start with is 2 basic ideas. All right? The 2 basic ideas are the graph of polar equation like r equals k and theta equals k, where k is a constant, are the basics. Anytime you have r equals something, it's going to be a circle whose radius is whatever the number is. Anytime you have theta equals some kind of number, it's going to be a line where all the points, doesn't matter what the radius is, are on that line. That's important. It's on the quiz. Might want to write it down. R equals is a circle, theta equals is a line. Good? All right, so we're going to do this on the calculator. So you're going to pull your calculator out and go to mode. And just like when we graphed sine and cosine, everything was always in radians, so you have to be in radian mode for this, which means on your calculator you're going to have to switch back and forth. Be careful. Radian mode. And then for the first time, we're going to go down and over past parametric to polars. So your radians and polars. Everybody good? Then go to your y equals button. What happened? It now says r equals, right? Everybody's good? Make sure you don't have a plot on the top. Okay, make sure you don't have a plot on up here. And then the question that we're doing on the notes is just what is r equals 2, I think. This is example right here. It says to graph r equals 2. So just put a 2. Then I need you to try two things. First of all, do zoom square. No, do zoom standard. My bad. Do zoom 6. Okay. And then do zoom square. And you should get it squared up and it should be a nice circle. Now, if you go to window, does yours say 0 to 2 pi here, 6.28? If you change the step down here to like 0.1 for the theta step, it'll just make your circle a little smoother, but it doesn't matter. You can leave it whatever. Okay, Kelsey, mode, radians, and polar. You find polar. Then go to y equals. Make sure you don't have a plot turned on and just put in a 2. And then we did zoom 6, enter, and then zoom 5, enter. But the zoom 6 made it sure it was going to be a window that it fit in. Everybody get it or not? Okay. Oh, is it? Did you change it to 0.1? That's too slow. You can't do that. We told you that before. But is it? Does yours say 0 to 6 or does it hit on? Go on and then go back to window. Okay, make it. Is yours in degrees or radians? Okay, that's why. Because if you're counting 0 to 360 by 1/10, that takes a lot longer than 0 to 6. All right. If we change this number to like 5, it just makes the circle have a radius of 5, okay? Nothing exciting. Now, the problem is the theta ones we can't do on the calculator. The other option is we could have something like theta equals. Well, theta equals means all the points that have this as their degree of rotation. So if I rotated pi over 6, I would go to this line. And then if I don't know what the radius is, I could go out any amount, forward or backwards, so I get this line. So if I told you to graph r equals 3, it should just be out at 3, right? With a radius of 3. But if I said graph theta equals 2 pi over 3, you would go to the line here at 2 pi over 3 on your graph paper, and then you would just draw a continuous line because you don't know what the radius is. Could be anything. So here's r equals 3. You have this one on your notes, I think. And here's negative 60 because we rotated negative 60 degrees. But this is the line that it would represent, all points on that line. So, can you do these three real fast? What would r equals 4 look like? This one is in degrees, but it doesn't matter. We don't even need a calculator, right? What does r equals 4 look like? Circle or a line? Circle. Out here at 4. Right here it says 4, so we draw a circle. Yeah, that's going to be really nice for Hofbauer. Yeah. Looks like I have a little palsy going on as I tried to draw that. All right. What about this one? This is not a circle. It's a line. Where's 3 pi over 4, guys? This is pi over 4, right? 2 pi over 4. 3 pi over 4. And the good news is you're going to have that pink sheet. It's labeled on there, right? Where 3 pi over 4 is, should be right in between these two. So then theta equals means it's this line that goes all the way through there. Any questions? What about theta equals negative 300? What is that? Line or circle? It's a line at 60, right? Or negative 300 would be positive 60, so it's this line. Nope, that line bent. Don't do that. 60 should go through to 240. That's a little better. All right, they got it. R equals as a circle, theta equals as a line. All right, one more idea, and you have to do this concept on the homework, and you have to do it on the quiz. There's actually a formula on your sheet. I hate the formula, but it's there. You can use it, okay? It's really law of cosines. It says if you plot a point at negative 460, so I go around to 60 and I back up 4, so I'm on this line, 1, 2, 3, 4. Okay? And 1, 105. Now, I don't have accurate graph paper to do 1, 105, but I'm just going to label it in here. This is 1, 105. Somewhere in between 90 and 120 here. What's another name for this one I put out here? What's an easy name? This is where the bench is, and this is where a pond is. This would just be 240, right? 240 would be an easy name for that one. All right, we want to know how far apart they are. This is what I'm going to do. I'm going to put a dot at the origin and connect these out. Ugh. So this is what I have going on. It looks like this. This is 4 units long, and this is 1 unit long. What is the angle in here? From 105 around to 240 would be how much? 135. Now, what I want to know is the distance from here to here. Is that a law of cosines problem? Right? X squared equals 1 squared plus 4 squared minus 2 times 1 times 4 times the cosine of 135. What mode does my calculator need to be in? Degrees. Now, you can also use, can you find it on here, guys? I just want to make sure you know how to do this, even if you don't like my way. On the sheet, it says the distance between polar points is the square root of, and then what does it say? R squared, which was negative 4, plus the other r squared, which is 1, minus 2 times the r's, which are negative 4 and 1, times the cosine of the angle in between them, which was 60 minus 105, or 105 minus 60. Does it matter? Yeah, I think this should be 105 minus 60. Actually, it won't matter. I lied. Okay. So let's see if we get the same answer. Yes. Well, you don't have to. You could have used the same numbers I did. Okay? Yes. His question was, could we have used 4 squared, 1 squared, minus 2 times 4 times 1 times cosine of 240 minus 105. Whoops. Oh my gosh, I can't write. Yes. All right. So make sure you're in degrees before you do anything. Doesn't matter if you're in polars still, but you got to be in degrees, as the question was given in degrees. All right, so 1 squared plus 4 squared minus 2 times 1 times 4 times Cosine of 135 gave me 22.65. Is that the answer, guys? Does that seem reasonable? If you want 1 this way and 4 this way, the distance between them is 22? What's wrong? I still need to square root. So I got 4.6. No, 4.76. Just kidding. So the distance between them I got here is 4.76. That seems much more reasonable. I'm going to try typing these other crazy ones in and see if I get the same thing. Here, I'll even do it on here. Okay. Mode. Degrees. The first one had a square root. And then what did it say, guys? So many parentheses. -4 squared plus 1 squared minus 2 times -4 times 1 times the cosine. We wrote 105 minus 60. Is that the same thing we got? 4.6? No, 4.76. Did I do something wrong? 105 minus 60. Did I put all the negatives in? I did. Did anybody else get either one of those answers? What do we do here? If we redo this and we do 60 minus 105, did I mess that up? I still get 4.6. Did I type it wrong the first time? Okay, so 4 squared plus 1 squared minus 2 times 4 times 1 times the cosine of 135 was the angle we found, right? And the square root, I think I did type it wrong the first time, didn't I? What? But we did it 4. Right, but it's okay. But I was doing it by law of cosines this time, and they should give me the same answer, and I'm trying to figure out what I'm doing wrong. 4 and 1, 60 degrees, add 180 is 240. The difference between those is 135, right? Is that what I'm typing? Why did I get 3 different answers now? This is not what I got the first time either. Oh my gosh. 4 squared, 1 squared, minus 2 times 4 times 1 times cosine of 135. I am in degrees, yes? No? Oh my goodness. Ah! And it still said radians. All right, so no wonder. Let me erase the last 5 minutes of video. These were all typed right. So this one, 4.76. This one, enter, and then I still got a square root. But no one was saying, I'm getting 4.76. That's what I asked you guys. Okay, so it does work no matter which of those you use. Let me go back and do one more thing. What if I did this one and I made it 60 minus 105? I think it should still work. Okay, everybody happy now? It still works no matter which way you type it. I'm happy now. The video is extraordinarily long because Offbar can't put her calculator in degrees. All right. So here's the formula. One more time. It's on your sheet. So let's see if we can do this one. Can you do these two? Use the formula if you want. Between 5, 310 and 6, 345. I don't think you have this one, but can you put these numbers into the formula on your calculator? If I were doing it by law of cosines, I would say how far apart are those two angles, and I'd use 35. But you guys can use the formula if you want. So I'm going to do it that way. You use the crazy formula if you want. I got 3.44 just like they did. Someone else get that using the formula? Okay. We have another example? Nope. All right. These are on worksheet 5. Is that right? Is it 5? Yes. Okay, worksheet 5A is the assignment. And I did cross off a few. I crossed off 7 this year. And I crossed off 20 and said it's extra practice if you want it. I already crossed off on your on worksheet 5. And I crossed off 30. That's it. The problems themselves are on the other side, okay? So the bookwork is on one side, and the graph paper for you to use is on the other side. It goes really fast. The first 5 are just plotting points or so. Then it asks you to do write couple names for these. Then it's just drawing graphs. And the last 2 are finding distance, I think. Questions? Anything you want me to repeat?